So in this lecture, let's understand about variable scopes. So variables have scopes. A variable scope refers to the accessibility of a variable in a given program or function. For example, a variable may only be available within a specific function, or it may be available to the entire C program. So depending upon the scope, we have two types of variables. One is local scope variables. So in short, it is also called as local variables. And global scope variables, which are also called as global variables. And let's understand more about variable scopes with some examples. All right, now first let's understand about local scope variables. So here I have a file main.c and I have a function main, and it is actually an empty main function. And let's create a variable inside the main function. So now let me create a variable. So here, this is a variable myscore, which is actually called as a local variable because this variable exists only in this function. So its scope is limited to only this function. So that's why this variable is also called as local scope variable. So now let me create another function. So now let me give the function name as, let's say, my function1. After writing the function name, so you have to give the function body. So you have to give these brackets. So here, this is start of the function body and this is the end of the function body. And also you have to mention the return type. So let's say this function doesn't return anything. So that's why we can mention it as void. And also this function doesn't take any arguments. So that's why let's mention void inside the parenthesis. That's great. So this is actually a function definition. And now let's call this function from main. So this is called as a function call. So this is a function call. So this is a function definition. And after that, so you have to give the prototype of this function. So more on that we'll learn later. So don't worry about that. So you have to copy this function prototype and you have to mention the prototype or signature of this function definition. So in the global space, and you have to terminate that with a semicolon. So this is a function prototype of function my function1. And now what I'm going to do is I'm going to assign some value to the my score here. So let's say 900. And after that, I'm going to print that. Printf value of the variable my score is equal to %d. And after that, I'm going to run this code and let's see what happens. So it actually printed value of the variable my score is equal to 900. That's great. And after that, what we are doing is we are calling this function, that is my function1. Control comes to here, right? And here I'm going to put something else into this variable. Let's say I want to change this to 800, right? And again, I'm going to print here value of the variable my score, and let me give 002 in order to trace the execution. Let me try to compile. And here it is. So you actually met with an error here that is saying undeclared. So here you can see that the error is at the line 31st, that is right here. So here the compiler is saying that, so this is undeclared or undefined because you are trying to change this variable, which is actually local to this function. So its scope is just limited to these brackets. So you cannot access them from some other function. So that's why these variables are called as local variables. You can access them anywhere you want inside this function body, but not outside of that. So what we can do is, in order to solve this issue, if you really want to access this variable from some other function, then what you can do is you have to make this variable as global. So that means move this variable from local scope to the global scope. So I'm going to cut this variable definition and I'm going to put that into the global scope. So now this variable is visible from all the functions of this file, main.c. So this variable is now called as global scope variable. So now if you compile the program, so the compilation is fine and we got the output. And here you can see that first we printed this. So that's why it printed 900 here. And after that, the main function is calling my function 1. So control comes to here. And here we are going to change that global variable, that is this variable. And its value is now changed to 800. And after that, we are going to print this printf. And so that's why this printf actually printed 800 here. And after that, this function returns here. So we go back to the main function and execute this statement, return 0. All right, so now let's see one more example. So here we have a small code and I want you to predict the output of this program. So here what's happening is we have two variables of the same name. So here you can see that there is a variable called value a in the global space, which is initialized to 4, and another variable of same name, value a, which is defined in the local space. So these statements are absolutely fine because this variable actually lives in local space and this variable actually lives in global space. So compiler has no issues, no conflict of names here. So that's why this program will compile well, no problem. The output of this program will be, let's see, let's run. So the output of the program is 67. So why is that? Remember that, so when the variable names are same between local space and global space, the first preference is always given to the local space. So that's why here value a is referring to this variable definition, so not this. So that's why value a will be 67 because the first preference is given to the local space if the variable names are same. So now this is absolutely illegal. So you cannot define another variable of same name. So this is actually illegal. So it throws error saying conflicting types for value a. Let me remove this. So now let me just modify this code. Let me put brackets here. So I will open a curly bracket here and I will close it here. So I just created a small execution body by using curly brackets. So now what do you think the output will be? So now the output will be 4, not 67. Let's see how. First, let's run the code. So here you can see that value a is equal to 4. So now what's happening here? Let's analyze. Here you can see that this is actually a local variable which is bound to the scope of this area. So this is a small execution body here. So the execution body starts at this bracket and it ends over here. So that's why the scope of this variable is bound to this area. So the moment execution control goes out of this scope, so this variable is no longer valid. So that's why. So the moment control comes to this printf statement, so this is no longer there. So this variable is already died. So that's why there is only one variable left, that is global one, right? So that's why printf is printing the global variable value. So always remember that when the execution control goes out of the scope of a local variable, the local variable dies. That means a variable loses its existence.